Hello everyone. Once again, welcome to KTHM e-learning channel. Let us continue the topic Michelson-Morley experiment. In previous lecture, we had learned purpose of Michelson-Morley experiment, that is to detect the existence of ether medium. Then we have seen experimental setup of Michelson-Morley experiment and procedure to obtain the path difference. As we had seen, when the monochromatic light incident on this half silver glass plate, which is at 45-degree angle, arranged at 45-degree angle to the direction of the incident beam, and the two mirrors M1 and M2 at a distance D. One is parallel to the beam and incident beam, and another is a perpendicular to the incident beam. Then this incident beam partially get reflected and partially get transmitted. This transmitted beam, the time required to travel the path from P to A and back to P. This we have calculated, that time to travel light ray from P to A and back to P, T is equal to twice D upon C, 1 plus V square upon C square. And the time required to travel the ray, this reflected ray, from plate P to B and back to P. From plate P to mirror M1 and back to plate P. This time T dash is equal to twice D upon C in bracket 1 plus V square upon twice C square. As this T is greater than T dash, this time required to travel along the direction of this velocity, this time is greater than the time required to travel in perpendicular direction, that T is greater than T dash. Then the time difference of the two paths. So the distance is same, but the time required to travel is different. Therefore, the time difference of two paths, delta T is equal to T minus T dash is equal to dV square upon C cube. This we have derived in previous lecture. If this whole apparatus is rotated through 90 degree, then this M1 is along the M1 is parallel to the direction of travel of the apparatus. This path PB becomes parallel to the direction of motion, and path PA becomes perpendicular to the direction of motion. Then T becomes T dash and T dash becomes T. If whole apparatus is rotated through 90 degree, then T becomes T dash and T dash becomes T. Then time difference of two paths. Then delta T dash is equal to T dash minus T. Substitute the value of T dash and T and simplify. Then we get delta T dash is equal to minus dV square upon C cube. This delta T is a time difference between the time required to travel the ray in the two paths before rotation, and this is the time difference after rotation. Then the change in time difference due to 90 degree rotation, change in time difference, that is the difference between this delta T and delta T dash. The change in time difference due to 90 degree rotation, delta T minus delta T dash. Substitute this value, delta T, and this is delta T dash. Then delta T minus delta T dash is equal to twice D V square upon C cube. This is a change in time difference due to 90 degree rotation. If we multiply it by velocity, then we get path difference. The path difference due to 90 degree rotation, let this delta is a path difference, is equal to this time difference multiplied by C. This delta T minus delta T dash is twice dV square upon C cube multiplied by C. Then we get path difference 2 dV square upon C square. Then the fringe shift. The fringe shift in interference pattern due to 90 degree rotation of the instrument. The expected fringe shift due to 90 degree rotation of the instrument path difference and the Prince shift related by this expression. Path difference is equal to Prince shift into lambda, where lambda is the wavelength of the source used. The path difference is 2 dv square upon c square, which is equal to n lambda. Therefore, the Prince shift n is equal to 2 dv square upon lambda into c square. This is the theoretically derived formula of the Prince shift. N is equal to 2 dv square upon lambda into c square. Michelson-Morley used the value that distance between mirror and the plate d is equal to 11 meter. The monochromatic light source uses sodium. Its wavelength is around 6 into 10 raised to minus 7 meter. The universal constant, velocity of light is a universal constant, that c is equal to 3 into 10 raised to 8 meter per second, and the Earth's orbital velocity is 3 into 10 raised to 4 meter per second. Substitute this value in this Prince shift expression, then we get n is equal to 0.37. It is around 0.4. This expected Prince shift, or the theoretical value of the Prince shift, is 0.37, which is approximately 4, or in percentage it is around 40%. This is the theoretical or the expected value. But when Michelson-Morley performed experiment, he could not observe any Prince shift. That this 40% Prince shift could be easily detected with Michelson-Morley instrument, because it is a highly sensitive instrument. Therefore, it can easily detect this Prince shift, because this Prince shift is much large. The experiment repeated in different seasons of the year at different location on Earth's surface, but no Prince shift observed. Michelson-Morley and his team performed this experiment throughout the year in different seasons at different location on the Earth's surface, but they never observed any Prince shift. This null result of this experiment shows that speed of Earth relative to Earth is undetectable. That is, the speed of Earth with relative to stationary ether is not detected. Its explanation is given by different scientists. That explanation we will see in next topic. Explanation of negative result of Michelson-Morley experiment. First explanation given by Michelson. Ether may drag along with Earth. That is, the velocity of Earth and ether may be same. Thus, there is no relative motion between Earth and ether. As there is no relative motion between Earth and ether, so the Prince shift is not observed in Michelson-Morley experiment. The second explanation given by Lawrence and Fitzgerald, bodies will get contracted along the direction of motion through ether. As per the scientists, bodies will get contracted along the direction of motion of the ether. Let L0, length of the body at rest, and L, when it is moving with velocity v. Then L is equal to L0 into square root of 1 minus v square upon c square. This is the original length, and this is the change in length due to motion. At L is equal to L0 square root of 1 minus v square upon c square. In Michelson-Morley experiment, the distance PA, that is the distance between mirror M1 and the glass plate PA, is equal to d along the direction of motion, while PB is perpendicular to the direction of motion. For PA is equal to d along the direction of motion will get shortened. That change in that distance is d is equal to square root of 1 minus v square upon c square. Due to motion along the direction of motion, this d shortens and it becomes t into square root of 1 minus v square upon c square. Then the time interval of light from P to A and back to P. This we have derived. T is equal to twice d upon c into 1 minus v square upon c square. This as per this formula, it change that substitute d is equal to d into square root of 1 minus v square upon c square. Therefore, t is equal to twice d. Is substitute this d upon c into 1 minus v square upon c square. If we simplify this, then t is equal to twice d upon c, 1 upon square root of 1 minus v square upon c square, which is same as t dash, which is same as t dash. Means t and t is equal to t dash. The time required to travel along the direction of motion and time required to travel the light beam perpendicular to the direction of motion same. T is equal to t dash. As t is equal to t dash, therefore delta t is equal to 0. No time difference in the two paths. That delta t is equal to 0. That optical path difference is equal to 0. Hence, no fringe shift observed in Michelson-Morley experiment. This may be the second reason of the negative result of the Michelson-Morley experiment. Third explanation given by Einstein. It is known as principle of constancy of speed of light. According to this explanation, velocity of light in space is universal constant and is independent of the relative motion. Therefore, it is along the direction of the motion of the apparatus in opposite direction of the motion of the apparatus, the velocity is same. Therefore, this may be the this is the reason of the negative result of the Michelson-Morley experiment. Postulates of special theory of relativity. First postulate, the principle of equivalence. The laws of physics are same, that is invariant in all inertial frames. This is the first principle. The all laws of physics are invariant in all inertial frame of reference. All inertial frames are equivalent and absolute inertial frame does not exist. This is the first postulate. And the second postulate, the principle of constancy of speed of light. The speed of light in free space is always constant and it is equal to c. And it is independent of the relative motion of the inertial frame. That is, light velocity is constant and it is independent of the motion of the frame of reference. Whether the observer is stationary or moving, or whether the clock is stationary or in motion, it not affect the velocity of the light. That is the principle of constancy of light. That's all in this lecture. Thank you.